Let's go ahead and start talking about the process of completing the square. So what happens sometimes is you're going to run across some quadratics that just don't factor easily. They're not going to factor in the way that we have learned. So if we can kind of manipulate those quadratics into the form of a perfect square trinomial, we can go ahead and get at those solutions. So perfect square trinomial. Here's your standard form. Super easy to factor. So you will always have the first term is going to be a perfect square. Your last term will always be a perfect square. And if you were to take the square root of your first and last term, so that would be a and b, you multiply whatever they are, and then you double it. You multiply it by 2. That should be what your middle value is. For example, we saw that here when we did our first example. So my first term was a perfect square. My last term was a perfect square. So the square root of x squared is x. The square root of 49 is 7. So that's 7 times x is 7x. Now, if I multiply that by 2, which would be 14x, that's my middle term. This is a perfect square trinomial, and we can jump straight from perfect square trinomial into this factored form. So again, always notice too on a perfect square trinomial, because you're squaring a number, it doesn't matter if it's positive or negative, that last term will always be positive. Your middle term is again 2 times the a times b, and your a and your b are just going to take the square root of those. So if we're going to complete the square, we're going to have to work a little backwards. We're going to take an expression and we're going to force it into the form of a perfect square trinomial. And how we're going to do that is we're going to take whatever the b value is, we'll divide it by 2 and square it, and we're going to add that to both sides of the expression, and then we'll be able to factor it nice and easy. So let's go ahead and do an example. We're going to complete the square. Now, if you look at that quadratic, you can see that is not something you can factor. You can't, if you think about it, you know your factors would have to both be positive. Two numbers that when you multiply them, you get 5, and you add them and you get 8. There isn't any. This one is not easily factorable. So we're going to force it into a way that we can factor it easily. So here we go. First thing that you're going to do is you want to isolate your x terms, put them on one side of the equation, move whatever constants you have over to the other side. So I'm going to subtract 5 from both sides. I get x squared plus 8x equals, and I'm going to have a negative 5. And what I want to do is I want to find a number that will complete the square and make this a perfect square trinomial. So how I do that is I'm going to take my b value. Here's my b value, it's 8. Remember, you're going to have to take your b, divide it by 2, and square it. So my b value is 8. So 8 divided by 2, square it. 8 divided by 2 is 4. Square it, equals 16. I always write this out because when you go to factor, this 4 is going to be nice and handy. So I'm going to need to add a 16. So that means I'm going to add 16 here, but now I've changed the value of my equation. I need to add 16 to the other side. Remember, what you do to one side, you have to do to the other. Now we are balanced. So now, check this out. This is a perfect square trinomial. I've got square root of x squared is x. Square root of 16 is 4. 4 times x is 4x. If we multiply that by 2, we have the 8x. So now I'm just going to go ahead and factor this. And what's really nice here, I'm just going to drop in my parenthesis, put the square. Your sign is always going to be the sign of the middle term. And here, of course, we don't have a coefficient in front of the x. I'll just drop the x in. And your value here is going to be half of b, which we already did that here. So that's what I'm talking about. I always just look to whatever I have here. And so that is a plus 4. Okay. So now the left side is factored. Equals -5 plus 16 is a positive 11. So there we have it. We have completed the square. Now I want to bring it to your attention. Now I'm going to try to keep going over this. I am so close to vertex form. If I were to subtract that 11, I would be in vertex form. Y equals x plus 4 squared. I'd subtract the 11 from both sides. And now we're in vertex form. My vertex is -4, -11. From here, I can also see my axis of symmetry is at x equals -4. I can also tell my graph is going to open up because my a value is positive. I don't see a negative there. And if I know if my graph is going to open up, I have a minimum. My vertex is the lowest point. So I have a minimum at y equals -11. Notice that minimum is coming from the y value of the vertex. Let's see, I can also see my domain. This is quadratic. My domain is all real numbers. And my range. Okay, your range is your y values. And again, your lowest y value is that lowest point on the vertex. So it starts at -11. And you can see it's going to go up forever. Okay, so we've completed the square. We've also moved it into vertex form, which now brings it back to 2, 1. And we've talked about some key features. So hopefully this will help you also prepare for your test.